Okay, hi. For chapter 2, I'm going to do just a video explanation on the importance part. So there are basically four subtopic in under chapter 2, but I will only focus on 2.1, the general idea of software maintenance, a type of classification of software maintenance, categories of maintenance concept, and also the evolution software system. Okay, for 2.4, I think it's better for you to read. It's not really important because it won't be asked in the assignment and also the quizzes. So yeah, so you just go read yourself. Okay, for 2.4. Alright, so let's take a look at the general idea of maintenance. We learn in chapter 1 like the basic ideas of what is software maintenance, what is software evolution. So maintenance is regarded as correcting error and enhancing the functionalities of the software. Okay, but in later time in ISO IEC 14764 standard, software maintenance is defined as the totality of activities required to provide cost-effective support to a software system. So activities are performed during the pre-delivery stage as well the post-delivery stage. Okay, what it's meant by totality of activities is the pre-delivery before you deploy your system, the software system. You need to have a maintenance plan. So after the post delivery, after you convert the deploy the system, we have the plan that we should follow, okay, one by one. Okay, so first classification type is intention based classification of software maintenance, like what we discussed in chapter 1, the corrective, the adaptive, perfective, and the preventive maintenance. Okay, so the purpose of corrective maintenance is to correct failures, process failures, and the performance failures. While adaptive maintenance is the purpose of adaptive maintenance is to enable the system to adapt to changes in its data environments or processing environments. While perfective, to make a variety of improvement, namely user experience, processing efficiencies, and maintainability. And lastly is the preventive, obviously to prevent problems from occurring by modifying the software products. Okay, so you need to know what are under corrective maintenance, preventive. Okay, so corrective, example of corrective maintenance is a program producing a wrong output, an example of processing failure, which is similarly a program not being able to meet a real-time requirement. So that one is example of performance failure. Alright, so basically corrective maintenance is a reactive process, which means that corrective maintenance is performed after detecting defects with the system. Alright, adaptive maintenance, example of the maintenance, adaptive maintenance, or you look at the blue color here, changing the system to support the new hardware configuration, converting the system from batch to online operation, okay, from the batch to online operation, and then changing the system to be compatible with other application. Like for example, the software can be used in both Android and iOS. So you make the system compatible with other application, or for example other platform. And other application means that you from your online shopping, you want to pay for your product, your stuff. So you can just go, the system can use another PayPal, for example, FPX, a credit card, to pay for your product that you want to buy online lah. Okay, so that is one of the example. You make the system compatible with other applications. So that is adaptive maintenance. And then we have a protective, which the program output can be made more readable for better user experience. Okay, it can be used by other people, like blind people, where it has audio read. Okay, so it also modified, the program can be modified to make it faster, thereby increasing the processing efficiency, and the program can be restructured to improve its readability, so to increase the maintainability. Okay, so perfective maintenance is mostly to improve user experience. It is more towards the efficiency and the maintainability. Okay, and then we have preventive maintenance. Obviously it is to prevent the problem from occurring, and so the example is, one should look ahead, identify future risks and unknown problems, so take action so that those problems will not occur in future when you use the system or the software. So preventive maintenance is very often performed on safety critical and high available software system. So the concept is software rejuvenation. It's a preventive maintenance measure to prevent or at least postpone the occurrences of failures or crash due to continuously running the software system. So for example, MATLAB, you can hold or can stop a pause if the system needs to analyze more data. So one way is it has this pause postpone how to say features, just to make it you can stop your laptop from using the system, the software, um, in like 24 hours time. So you can at least postpone the crash, okay, due to continuously running the software system. So it involves occasionally terminating an application or a system, cleaning its internal state and restarting it, okay, without any disturbance to the data, okay, or severe failures in the end. Okay, and then we have activity based classification of software maintenance. Remember Kitchenham suggests the correction and enhancement activities, two categories, okay, correction and enhancement. So correction is obviously to fix defect, to fix failure. Enhancement is same as you do the preventive, the perfective, adaptive. So that one is enhancement category, same as what we Swenson has suggested in 4 of his intention based software maintenance classification. Oops, all right. Okay, so enhancement is basically modify some existing requirement, add new system requirement, which we discussed in chapter 1, and also to modify the implementation without changing the requirement implemented by the system. And okay, so this is another evidence based classification from this 4 cluster: business rules, software properties, documentation, and support interface. Evidence means that you have to make sure that you follow these 4 cluster, and then you give your evidence based on this 4 cluster. So in terms of business rules, the type of software maintenance that you should do is enhancive, corrective, and reductive. In terms of software properties, you need to have adaptive, performance, preventive, and groomative. And in terms of documentation, updative and reformative. Obviously, if you bought your maintenance, you have to also update your documentation, because when you do changes, obviously if you do maybe your program changes, so your code need to be changed because you add functionality or add requirements in your changes. So your documentation also need to be updated So you have to follow this cluster documentation, you have to update, and you have to reform your documentation. And lastly is the support interface. Support interface, evaluative, consultative, and training. Must have training, because if you change, sometimes when you change your software, it might require new skills to use it, so you have to also update your training, how to train staff or how to train people to use the software. Okay, sorry, so this it's a bit like saying it. Alright, next is the evidence-based classification of software system. The maintenance activity is based on the changes in 4 kinds of entities. Okay, 4 kinds of entities is, the first one is the whole software changes, the external documentation, the properties of program code, and the system functionalities experienced by customer. So later in the model, you will see we do the record, redesign, respecify. Okay, so you have to keep in mind, if evidence-based classification of software maintenance, the classification of maintenance activity will cover 4 kinds of activities: the whole software, the external documentation, the properties of their program code, and also the system functionality. Okay, so this is the training, consultative, evaluative. So this is important for the documentation, the support interface part. Reformative, updative is for the documentation update. Grummative is under the second one, which is the software properties. Alright, so enhansive is corrective, and reductive is the first one. Okay, so there are 12 important evidence-based classification that you should know, okay, from the low and high. And we also have decision tree based criteria. Okay, so if you look at this how to say this type of software maintenance, we have 12 activities that you need to follow. Business rules will tackle on D1, 2, and 3. Documentation B1 and B2. And then the software properties C1 till C4. Okay, so what is A, what is B, what is C and D? You look at this. A, you have to ask the question, was software changed? If no, you just update the support interface. Okay, if yes, you go to the B question, which is, was source code changed? If no, you update the documentation only. Okay, you update the documentation only if no. And then if yes, you go to the third question, which is, was function charged? So if yes, you go to the business rule and you do the enhanced, corrective, and reductive. And if no, software properties, adaptive, performance, preventive, and grummative. Okay, alright, so it's okay lah. You can just refer to your slide. I'm just talking here and then see my slide here. Okay, this is you can just go through this, and then this is the type of question that you should ask. Okay, so it's actually raining here at the moment when I rakam this. If you can hear the rain, just bear with me lah. Okay, the 4 categories and the concept that influence the maintenance process have been illustrated in the following figure. So we have the maintenance process, the categories of maintenance concept, the maintain product. What is the product that you need to maintain? So okay, here. And then we have the people who involve, okay, with the maintenance organization, human resource, maintenance process. The next one is the maintenance type, activity, investigation, modification, management activity, QA activity, resources, and lastly is the maintenance organization process. Okay, so where you have to ada the agreement, SLA, okay, the agreement, and also the change control, configuration management, which we will learn in later chapter. Okay, what is the product? Product is the coherent collection of several different artifacts. Source code is the key component of software product. So obviously what you try to maintain here, the product is software lah. Okay, when you talk about software, obviously when you change software, you cannot avoid to change its source code. Okay, so that is the key component of software product. And product upgrade, baseline is an arrangement of related entities that make up a particular software configuration. So any change or upgrade made to software product relates to a specific baseline. Artifacts can be a number of different artifacts used in design of software product, macam your textual graphical document, component of the chef product, COTS product, and object code components. Okay, so we talk about artifacts again. Like for example, you are handling object oriented project. So obviously you will see lots of UML, class diagram, you will see a lot of sequence diagram, so on. Okay, so if you change certain part in your software, obviously you have to change your graphic juga. Okay, your class diagram also, your UML. Alright, so this is a stage model maintenance task: initial development, evolution, servicing, phase out, and close down. But okay, this is difference from different project. Okay, but this is where you can just you can see in terms of evolution, maintenance task that is involved is correction and enhancement, because you correct and you enhance. That's why you are actually evolving the software. And then for user population, it's for small user only. Okay, so maintenance type, we have investigation activity, modification, management activity, and quality assurance activity. This one we can just read, because it just to see the 4 types of maintenance activity, where you can maksudnya you can choose when you start to do your maintenance activity. The first one, obviously you have to investigate. You need to modify the activity for your maintenance. And management activity, how you handle what kind of activity related to this management of the maintenance process. The quality, how you ensure this quality. But we will go to this part in the later chapter, because the investigation will be more specific in chapter 4. Modification to quality assurance will be in chapter impact analysis. Okay, how you make sure you actually doing the right thing. So this quality assurance, all of this activity will be explained in later chapter. Okay, individual level maintenance process, followed by maintenance personnel to implement the specific change request. Okay, so this is the maintenance, the 2 different level of maintenance process followed within the maintenance organization. We have individual level and we have the organizational level. So for individual level, it follows by maintenance personnel to implement a specific change request. And for organizational level, this is this will to manage the change request from maintenance personnel, users, and customer client. Okay, so from individual, just a simple specific change request. But for organizational level process, the whole thing is involved: the maintenance personnel, sometimes maintenance engineer, users, and customer. Okay, hopefully you can see the slide still. The major elements of maintenance organization: event management, configuration management, change control system. Okay, so this one just we will see which part of event management that which part of group that will handle this task, because this is like still in a very preliminary part of the chapter, the basic, the fundamentals. Okay, but you need to know we have three major event elements. the event management, siapa yang akan handle the change request, from various sources. Configuration management, who will be maintains or who will be monitoring all this configuration. And change control system, what are the tools that we can use to control the system, to control the changes in the maintenance process. Okay, so this one also okay, so this one is more towards the maintenance organization process. Still again, we have level 1, level 2, and level 3. Level 1 is the group files problem report, identifies the technical support person who can best assist the person reporting a problem. So okay, so client can come to will come and then saying that, okay, I need to maintain my software. So a group of files problem report will be identified and then will be reported to a person that in charge of this problem, okay, that will assist the technical support, that will assist to identify what is the main problem and then which group that we need to convey this problem to. So level 2, this level includes expert who knows how to communicate with user and analyze their problem. Okay, so these people recommend quick fixes and temporary workarounds. And level 3, this level 3 includes programmer who can perform actual changes to the product software. Okay, so we have a different level of organization, maintenance organization. Okay, bukan semua akan buat maintenance, bukan semua akan ubah coding, for example. Okay, it must be, the changes must be something that is worth changing. If not, you will macam buang duit you, buang masa you to do the maintenance. The 3 people-centric concept related to the maintenance are as follow. Maintenance organization, organization that maintains the product. Client organization, a client organization that use the maintain system. A client organization uses the maintain system. And human resource includes personnel from the maintenance and client. For both lah, human resource will handle both maintenance organization and client organization. People where finally the following user and customer issues affect the maintenance. Okay, so there are 3 types of user and customer issues that will affect maintenance. The size of it, the size of customer base, and the number of licenses they hold affect the amount of effort needed to support a system. For example, for Turnitin, for example, 1 PC, 1 license. Okay, so if you were to change, if you have like 100 PC, there will be more effort to do, to support the system, to maintain the system. Variability, high variability of customer base impact the scope of the maintenance task. Different user will have different perspective, different needs, different feedback. Okay, so the variability will also affect the maintenance. And lastly is the common goals. The extent to which the user and customer have common goals affect the SLA. Okay, so the SLA is the agreement where both party need to agree. Okay, macam for the maintenance engineer, the side will say we will only maintain until this period. Okay, and then the customer need to agree with it. So the common goals is also, it's hard to be achieved, so that's why we need the agreement, so that in future there won't be any problem with it. Evolution software system. Okay, so evolution of software system, we're now in 2.3. The term evolution was used by Mark Happen in circa 1965 to define dynamic growth of software. So dynamic maksudnya boleh berubah-ubah lah. So software evolution is used by the Mayer Lemons, and they propose 8 broad principles allows about how certain types of software system can evolve. Alright, so the one that you been looking into for the assignment, the first assignment, which is the SPE. But before we go to that part, let's take a look at this. Software evolution is the combination, according to this lower J author, combination of people, existing software, machine, which is CPUs, and resources. Resources obviously is money lah. And the software will evolve to become a revised software. Okay, a new types of software, a better software. So Keith Bennett G. Shu used maintenance for all post-delivery support, whereas the use of evolution to refer to perfective modification. Perfective modification triggered by changes in the requirement, because you correct and you enhance. So that is the evolution. You perfectkan the modification. From correction, modification, you perfectkan, it will become evolution. Okay, software evolution, which is more better. So software evolution is studied with two broad complementary approach: the what and the why, and the how. So the explanatory, which is the what and the why, this approach attempts to explain the causes of software evolution, the processes used, and the effect of software evolution to the company or to the organization. And the explanatory approach studies evolution from a specific viewpoint. Okay, so while the process improvement is, which is we answer the how, this approach attempts to manage the effects of software evolution by developing better methods and tools, namely the design, maintenance, refactoring, re-engineering, which we will cover more detail, more depth in the next chapter. Okay, so the process, but bear in mind the process improvement approach studies evolution from an engineering viewpoint, is considered as also a reverse engineering, which is the re-engineering and also reverse engineering and also refactoring. Okay, so we have three types of the taxonomy, SPE taxonomy: specified, problem, and evolving. Sorry. Okay, so SPE. So Lehman observed a key difference between software developed to meet a fixed set of requirements and software developed to solve a real-world problem which changes with time. Okay, so the observation leads to identification of the S specified, P problem, E evolving programs. The S type, like you dah belajar, you dah answer for your assignment, is like it said, is specific. Specific means that macam 2 tambah 2 is obviously 4. It's very specific. That is how the formula is. Macam 1 plus 1 is 2. So that is already specific. So that's why calculator, you cannot change. It's in real world, you cannot change. So we refer this as a specified type program, where you can, the correctness of the programs, okay, here the correctness of the program with respect to its formal specification is the only criterion of the acceptability of the solution to its stakeholders. Macam yang saya tadi lah, the formula 2 darab 2, 2 multiplied by 2 is 4. So you cannot simply change, because that is the formula, that is already specified. So no one can change that. Like for example, the calculation on the lowest common multiple of two integers, the perform matrix addition, mostly the calculation. Okay, calculation, no other way of, changes. So it's a specified. So you need to make it stay like that. While problem is based on practical abstraction of the problem. Instead of relying on a completely defined specification, we can change it with how we understand. Okay, contoh lah. Okay, like a program that plays chess program. Okay, this is like the simple way to understand it. In chess play game, the game can be set up into having 2 or 3 solution. Okay, if the person moved to the left, what happened? If the person moved to the front, what happened? Oh my god, battery running low. Okay, right. Okay, I solved the problem of battery tadi. Okay, so the problem type, okay, the P type, the requirement can be more flexible. Maksudnya, if let's just a game tadi lah, so if you move to the right, there will be a different solution. Okay, so the problem is based on the problem, what kind of problem, and how many solution that you can think of. Okay, so that is one of the example, like the chess. Another one is you can think of okay, traffic light, for example. Okay, this traffic light can use weight. Okay, how many cars? Okay, if this this side ABC, so if the A side is more cars, so the green light will how to say, will what is the word, will project more, okay, compared to the other side B and C, because there's no car. Okay, another way of solving the problem is by, you know, the recognition lah, how many cars. Okay, that is involving a camera lah. So camera will detect how many cars in this lane, and if the car is more in this in ABC lane, so the green lights will project more, okay, longer than the lane that has less car. And also we can suggest by timing. Okay, this is what we always do in Malaysia. We use timing, 2 minutes for each lane. So you see, this is example of a system in real life system that you can solve the problem using different kind of solution. Okay, different types of solution. So this is what we consider as P type. Evolving. Okay, the evolving program is one of the embedded in the real world, and it changes as the world does. So this program mechanizes a human or society activity and make simplify assumption. Okay, so this is the evolving part is for me is the aviation system. Okay, aviation system. Walaupun the pilot need to follow the system, the aviation, the monitor or the system as accurate as it is said. Okay, tapi E-type means that the pilot can also change the action. Contohnya, instead of they landing terus based on the aviation system, aviation suggestion, they can divert, okay, based on their own because this is like this is the evolving program. You can change upon stakeholder opinion, upon the pilot opinion in this case lah. Okay, so something that we can change. So the real world is outside, and you can as long as it is within the how to say, it is within the scope of the problem, then you are safe lah. You can just modify, you can evolve it around. Okay, so this is the SPE taxonomy for the E-type. Okay, you need to give more example. Okay, so this is the E-type programs with feedback, and lastly, for this chapter, that I want to cover is the law of software evolution, which we already discussed in chapter 1. There are 8 laws. Continuing change. What is continuing change? It is related to the E-type programs. Must be continually adapted, else they become progressively less satisfactory. Mesti sentiasa evolve, if not bosan. Sometimes the games, after certain period of, after you reach the level, the end level, obviously it is not an E-type. Okay, so it can be regarded as P-type because it's problem based, but it is not continuing change. So law of software evolution mesti continuing change. Okay, applied on the E-type program only. So increasing complexity. So as an E-type program evolves, its complexity increase unless work is done to maintain or to reduce it. Self-regulation. The evolution process of the E-type programs is self-regulating. Conservation organization stability. The average effective global activity rate in an evolving E-type program is invariant over the product lifetime. Okay, number 5 is conservation of familiarity. Mesti mengekalkan familiarity supaya it is easier to maintain. Continuing growth. The maintain user satisfaction with the program over its lifetime. The functional content on the E-type program must be continually increased. Okay, so basically I am doing this recording at exactly on near my window pane. So paham lah mun ada dengan bunyi hujan, no? But I'm going to just continue. I don't care. Declining quality. So make sure you won't decline the quality when you change. It should be improve the quality of the value of the software. And lastly, the feedback system. The evolution process in E-type program constitute multi-agent, multi-level, multi-loop feedback system. Okay, need to have a feedback system, because if you want to change, obviously it's from the feedback of the users. Okay, so I'm not going to explain this, you can read yourself. Okay, and this one, the evolution of FOS system, the codes, this is just something that you should read just for your knowledge lah, tapi for our assignment and for our quiz, it won't be out. Okay, you know that there's no final exam. So yes, I'm going to release another exercise assignment for you, just to make you comfortable with how software evolution is and software maintenance is. And this is actually a very interesting topic. Mun si hujan, okay lah, but the bising one, I hope you understand now. Okay, that's all from me. Good luck. Just read and understand your try to understand and try to find latest examples of software that it is considered as specified problem, and also the evolution, the E-type. Okay, so I think that's all from me. Thank you so much for listening. I love you guys. Okay, bye.